Hi, this is Bhupender, and in this short video I will take you through a critical vulnerability called log4shell in Apache's log4j. The word shell, I guess, is used in the vulnerability's name to emphasize that the attacker can easily get the shell access upon successful exploitation of the vulnerability, which gives full control to the attacker on the compromised server. That is why log4shell is rated highest value of 10 on CVSS 3x severity scale. To start with, we will try to understand why log4j is used by going through its architecture, which all components of log4j are vulnerable, and how the vulnerability is triggered. Let's get started. Log4j is an open source logging utility by Apache Software Foundation for logging services. It provides insight on what might have gone wrong during the software execution or automation of a Java-based application. As far as the architecture goes, Log4j has three main components: logger, appender, and layout. And then the other supporting components like level, filter, object renderer. While manager is a central component to manage the entire log4j framework. Log4j supports multiple substitutions and lookups inside the logs, and one of them is JNDI, Java Naming and Directory Interface Lookup, which was requested back in 2013 as a feature request for the open source project. It was accepted and then implemented. It is the very same JNDI lookup that causes the vulnerability to exist in this software today. But what is JNDI? JNDI is an interface that provides an API support to multiple protocols like LDAP, DNS, and RMI, to name a few. LDAP, on the other hand, is an open and cross-platform lightweight directory access protocol that provides a communication language to applications required to communicate with the directory server. Directory services contain user information like username, email address, password, department name, computer accounts, etc. And when an application needs to fetch one such directory resources from the directory server, then LDAP protocol is used. MS80 is an example of such a directory server. This vulnerability exploits the JNDI lookup functionality. An attacker can trick the vulnerable server to a malicious LDAP server, which then delivers a remote command to the vulnerable server instead of serving a directory resource. Let us see that flow of vulnerability exploitation. Before we see the flow of the exploitation, let me explain the components used in the POC. Here you are seeing hacker running malicious LDAP server on the left hand side top. It also is running a web server on port 8888. Left hand side bottom you have a hacker computer from where the first malicious command will be issued, and on the right hand side a server hosting vulnerable applications running on HTTP 8080 port. Since the vulnerable server has log4j, which in turn has LDAP JNDI, the command issued by the hacker triggers an LDAP lookup from the vulnerable server to the malicious LDAP server. This LDAP server then delivers the command payload to vulnerable app in response to its LDAP lookup. Command is delivered as a Java class by HTTP server running on the hacker server. Here is the first command that hacker issues. Let us dissect the command by dividing it into three blocks. Here, the first portion of the command is a simple curl request to the vulnerable app, which is listening on port 8080. Second is the header injection with LDAP JNDI, which triggers the lookup to the malicious LDAP server. And last portion is the command payload. Here you are seeing a command payload which is base64 encoded, which translates to a netcat reverse shell as depicted here in the diagram. Let us now go and see the POC on the next slide. Here you have 4 consoles open, one hacker server left hand side top, and then hacker computer, and third one is vulnerable server on the right hand side top. You can see the IP addresses of all the machines. Fourth console is just for reference to copy and paste the commands. Let us begin by issuing a command which executes successfully, and to decode this command I'll go to a base65 encoder, which is an online utility. Let me use decoder here and paste the encoded content, click on decode, and as you can clearly see, all this command does is creates a file inside the temp directory of the vulnerable app server. And to validate that, we'll go inside the temp directory, list it, and indeed you have been hacked. File has been created there. Now let us change the command payload, and instead of creating a file, execute a reverse shell to gain complete control of the vulnerable server. Before we do that, let us first ensure that a listener is running on the attacker server, for which I will use a simple netcat listener. Second, once the listener is being staged, let me decode and show you the content of reverse shell. It is important that your payload matches with the listener that you have just now started or going to start. Now here it's a simple netcat to the hacker IP address on port 9001 with a shell execution. Now I will start the listener and execute the command. The moment command is issued from the hacker computer, a shell is created on the hacker server. I will use ifconfig to validate the shell belongs to the vulnerable server. We not only get a shell, but a shell with highest privilege user account root. Using this high privilege access, one can run any command on the server or scan connected devices in the network and move laterally. Possibilities are immense. Hacker can now make directory, delete file, extract sensitive information, and here I'm demonstrating creation of a directory inside temp folder by listing the temp directory with ls-la option. Will also look at the time it was created just to validate that it was the command ran on hacker server that created this directory, and indeed that is the case. As the last section of this POC, let me very quickly show you the server-side console logs on the malicious LDAP server. Here you can see as soon as the command is issued to the vulnerable app, lookup reaches to the LDAP server, which then returns the payload in response of LDAP lookup from vulnerable app. Payload is served as a Java class. These are the lines I would like to draw your attention upon. Receive LDAP query with payload as command, and this is the command content. And then this LDAP server redirects the request to the hosted HTTP server on 8888 port, and then delivers this exploit Java class to the vulnerable app server, and that is how this remote code execution works. This concludes the POC, and I thank you all for watching the video.